Okay, good morning. Does anybody know what AI is? Okay, right. I had a friend to me, say, "Not you too. Oh my God, everybody's going in." People are really scared of the hype in AI, which is totally understandable, right? For me, I've just kind of looked at it as an opportunity to do something a little bit new. You spend 20 years working in legacy code, and it's kind of like you feel like you've seen a lot of things, and you're able to contribute an awful lot. But this is an interesting new area of practice. So with this, I just want to go and say that this talk is about where AI meets code. And it's not about tools. It's not about how to build AI into your products at all. But it's really about how AI can be used with coding itself, coding and design, okay? And this is an area which I haven't really seen too many people kind of get deeply into. So I've been running experiments and working with people for a while now. And in this presentation, what I'm going to do is I'm going to give you a little bit of a background about artificial intelligence, okay, just a small amount. Then we'll get into a set of techniques that should hopefully go and expand your sense of what's possible with a lot of these things. So the thing which is really frustrating right now about the use of AI, right, is that the main vendors that we see out in the space, they essentially have black boxes, right? You look at OpenAI, you look at Meta, you look at Gemini from Google and stuff like this, and there's basically the LLM architecture, which is something which people are kind of aware of now. There's lots of tutorials about this sort of thing, but you don't really know exactly what's going on behind the under the hood. Because essentially they're all in competition with each other. They're all trying to make their technology better. So the thing that's kind of funny about this is if you want to go and use this stuff effectively, you either take that deep dive into how LLMs work, and you hope that you aren't kind of missing something extra secret sauce that they placed in things. And it's kind of a laborious process. I do recommend 3 Blue, 1 Brown videos on YouTube. Excellent videos that go and give you the internals of LLMs and stuff along those lines. But the space is growing all the time. The technology is fastly changing. So what I've tried to settle in is kind of like developing a model that helps us from an experiential point of view when you're working with LLMs, because quite often, if you have a good working model like that, what you're able to do is you're able to go and sort of develop an intuition for what's going to work and what's not going to work very easily. And it helps you in your practice. So let's kind of jump into that. I call this the surfacing model, okay? And it's rather simplistic, but it's also something which I think has some power for you. Okay, so imagine that you're basically looking at a set of concepts in space, right? Everybody's familiar with graphs, right? Network graphs and stuff like this. You can imagine that out in front of you, you have all these concepts, which are dots, and you have lines connecting concepts that they happen to be associated with each other, right? And within an LM, essentially, there's a lot of work that's done through all the training to go and actually form probability associations between different concepts, different tokens and stuff that you have within the system. So imagine that this stuff is all in front of you as you're working. And then essentially when you mention in a prompt some concept, for instance, imagine that that thing is pulled towards you, okay? And the interesting thing is that when you pull that concept towards you, a lot of other associated concepts come along for the ride, right? They get pulled towards you also. And this kind of model kind of explains, in a sense, what happens when you're kind of you're working on something and you use the word property, for instance. And the context is ambiguous, and then you start to mention programming, and it pulls up all this associated knowledge that is connected to what the word property means in a programming context. So this is a nice way of going kind of looking at these things. And it kind of helps us as we go forward and look deeper. So you have this space in front of you. You have this cluster in the cloud, right? Metaphorically, the cloud, of all these concepts that are available to you within the LLM. And as you start to converse with it, you start to pull some of these things towards you. So why am I talking about pulling things toward us? What has to do with this? Essentially, over time, quite often, LLMs lose a bit of context. It seems like knowledge dissipates in a sense. And this has to do with the context window that we're going to talk about in a second or two. Essentially, if you work in a session for a period of time, you'll start to notice that you get really good answers in the beginning, and then as time goes on, it starts to lose a little bit of knowledge. And it has to do with basically inherent limitations within LLMs these days. So this thing of going and saying, OK, I want to go and actually work with this thing, and you get it pulled towards you, is kind of a good mental model for understanding how you actually interact with these systems. And it's very funny. It's kind of like when you lose your keys, what do, right? The first thing you do is you think, what was I doing when I last had my keys? And you basically go through and you try to find a memory of something that you were doing when you last had your keys. And then you kind of hope that once you do that, it pulls the other concept of the keys towards you. So this is the way our human memory works also, right? We're basically trying to go and sort of find associated things that are going to bring more towards us, more in the conceptual space. So this gets us to context windows. I'm sure you've heard this terminology if you've worked with LLMs at all. But the context window is really this notion that there's only a certain amount of stuff you can work on at a similar, in a session at once when you're working with things. And quite often what happens is you have this context window for a session, and basically as you work with it, all the prompts you place there get placed in the context window. And it's almost like your working memory in a sense. And you can view it metaphorically as basically how much can you be aware of at once in an LLM. And you'll hear vendors talk about different things related to context window, like how big it happens to be. Very early on, you can only fit about 4K tokens within it. Now we have like some vendors saying that you can have like 2 million token context windows. The thing about this, though, is that it seems that even when you have these very large token windows, you have this particular context windows, you get into the space where that dissipation problem still occurs, right? And there's an interesting thing that happens with these large context window models. And it's interesting that when you basically do some testing, you kind of discover that as the context window starts to fill up, it's kind of like the things that are remembered are most likely the things in the very beginning of the context window and the most recent things you've placed there. And this is called the lost in the middle problem, right? And the way they test this, there's something called a needle in a haystack test, where you basically sort of like mix the names of pizza ingredients within, like this text that you place within the context window. And you say, OK, give me a list of all the ingredients that have been listed inside this thing. You'll find the ones at the beginning very easily, and the ones at the end, but the ones in the center doesn't find quite as easily, right? What I find fascinating about this is that this is very much the way that human memory works also. In human memory, there's something called the serial position effect. And it's kind of like if you start having a conversation with somebody, chances are they're going to remember the first thing you said and the last thing you said. So I'm going to make sure I say something profound as the last thing today, right? So we call these the recency effect and the primacy effect. And I don't think this is really an accident. I think that with so much of, as much as we don't like to anthropomorphize these systems, a lot of them really are modeled upon things that we do as humans, right? And the way that our minds theoretically work. So yeah, that's kind of an interesting thing with that. So we have our context window. And one of the things that they kind of point out in that paper about this is that essentially if you have multi-step prompts, quite often that lost in the middle problem becomes a bit more profound. And a lot of this really has to do with the way that the processing happens in transformers. So the way things work is like if you know the order of algorithms, like an n-squared algorithm, an order n algorithm, by default, a lot of these LLM algorithms are like order n to the fourth, right? So this is very heavy processing that's necessary with these kind of things. So there is kind of this computational bound that exists for the LLMs currently these days. And knowing that kind of helps us out when we're trying to organize our work. So the thing I really kind of hypothesized in a sense is there's almost like this sense of a logical attention, and it's much smaller than the context window. And we can sometimes overload it, and when we do, it starts to dissipate. And when we change focus, it's kind of like it takes a little bit of time for it to go and actually re-jibe with what we're trying to work on. And it's just like as a human, it's like if you and I start talking about something, and then I switch because somebody over here says something about cars, I'm going to lose a bit of the context I have with you, and I'll be over here thinking about cars. So we can think of this attention roving as something that happens in LLMs by default. So having said that, and that's our backgrounder, I do have a bit of a mental model that I kind of use when it comes down to using AIs for design and coding. And it's really just kind of like these three pieces. Essentially, you can use these things to generate work product, or to basically sort of discover reference for things, like you're hunting up like information about a particular API, for instance, or a particular language feature. And the third thing really is ideation, right, which is kind of like going through that entire process of trying to go explore alternatives and stuff along those lines. And the way that we actually do these things, it really depends upon our context. So work product. This is the one that everybody's been trying to do for a long time now, right? The goal is to go and actually have LLMs generate code for you that you can place into production without having to do much further scrutiny in a sense. But we know that the hallucination problem is real with this technology. So as a result, we have to be cautious about many different things. We have to be very cautious to make sure that what we produce is safe, that it has high quality, both from the requirements point of view and the implementation, like we are asking it to produce the right thing, that it actually produces the right thing. But in all these cases where you're trying to go and generate work product, it tends to be high validation work. You need to actually do the work to make sure that the thing that's produced is suitable for production. And we'll have more to say about this a little bit later. Reference, this is something that I'm sure as programmers you're doing all the time now, which is like, OK, I've got a question about how this language feature works. Let me just go and ask, right? Or what's the API for this particular service? And I'll go and give you answers. And the thing about this is that it's kind of nice, and it's useful. But again, hallucination, you may not get the answers that you really need. But the thing that's nice is that the validation can occur in the work when you do this. And what I mean by this is essentially it's like, you You can try out what it gave you about this API, but your compiler's going to tell you, hey, that's not quite the right API. There's something a little bit wrong there. So you get to find out very quickly whether there was a mistake there or not. Okay? And the third thing is ideation, trying things out, exploring things, generating things. When we're doing this sort of thing, we just make the choice not to use what we're basically producing directly, but actually kind of scrutinize things. And I love this use of LLMs to go and actually sort of explore all sorts of design alternatives. And quite often, it's funny, I'll say, hey, give me 3 alternatives for this. And maybe I don't like any of those, but it triggers my thoughts into another area. And maybe there's another one I haven't thought of that ends up fitting pretty well. But I wouldn't get into that triggering space except by going and asking for a bunch of alternatives. So here's the thing. When we're basically working with AI, essentially it suggests and we decide. We are the humans in the loop. So let's go and launch into a couple of techniques about this. One I have that I call making projections is pretty powerful, and I use this all the time, right? So you have some code, and you take it and you just drop it into a session, for instance. And this is not the full class. It's like 2-3 pages, for instance. And I go and I say to myself, wow, I wonder how I could understand this in a more terse way. Well, gee, what's really terse? Mathematics is terse, right? So what I did is I said, OK, give this to me in math. And it gave me something that was really verbose and had a lot of English in it and stuff like that. So I said, OK, can you basically produce a mathematical description of this using LaTeX, the mathematical formatting language? And then I took the LaTeX and I pasted it into a tool, and it gave me this. And this is a mathematical summary of what that class is actually doing. And this can be very useful when you're doing things which are kind of computational, but maybe the computations, maybe the actual functionality is kind of hidden by the syntax of the language. There is still that issue with hallucination. It may not be absolutely correct, right? And that that's a possibility. But here's the bet that we make when we do this sort of thing. The more different directions that we can approach something that we're working on, the better off we are because we can see things from different vantage points and we get to think about, well, gee, is this correct? Is that right? Is that wrong? This kind of thing. So forming projections tends to be a very useful thing to be able to do. And LLMs kind of excel at that sort of thing right now. So another example. One thing that people don't really do very often is kind of like, here I've got a design of a class, a couple of classes and stuff like that. What does it look like as a state machine, right? Turns out, right now with many tools, what you can do is you can say, OK, give me a state machine representation of the class. And here's a set of classes that I basically worked with. And I said, OK, give this to me using plant UML syntax, because that's like a well-known syntax for these things. So I take that, and I drop it into a diagramming tool, and I get this, right? So again, this is looking at the same thing from another direction. It may not be quite right, but the more directions you have, the more information you have to go and understand something. So there are many different possible projections that you can have. And you could do things like, oh, translate this code into a Shakespearean sonnet, but that might not be very valuable for you, right? But I love doing this thing of mathematics and diagrams. The one that I really love more than anything else, though, is projecting to another programming language. So you have some Java code, and you say, please give this to me as Haskell, right? Please give this to me as Ruby, right? And it's nice because, again, with that other point of view of seeing things, it's useful. You can actually go a little bit more abstract than just a straight translation and say, OK, take this thing and change it to functional style, or change this thing to a more stateful style, right? And get these different ways of approaching things. Have you ever used Google Translate back in the day, right? And you paste something into it, and it gives you the translation. And don't you just love to flip it over and see just, OK, you translate this way and this way and this. You can do the same thing with this, OK? I like to do this in a separate session. Once I've translated Ruby to Haskell, I'll take the Haskell, drop it into another session, and then basically go ahead and sort of like see if I can translate it back and what does it look like. This is a little bit of a self-check to go and understand where things stand. We're going to talk more about this a little bit later. I said use a different session. Why did I say that? Because quite often you don't want to go and have the knowledge produced in one session, polluting the knowledge in the other session. This is a persistent problem we have right now, is session transport. How do you actually sort of like persist a session over time? How do you get meaningful information from one session to another? Because we know that sessions tend to degrade over time. Okay? We'll talk about that more later. Lensing. Here's another different technique you can use. And I love doing this one. Okay, I dropped in a class. Okay, here's the class I kind of listed in here. I said, give me the seven most important responsibilities in this class. And it listed a bunch of different responsibilities. And I looked at it and I said, OK, these are kind of interesting, but some of them don't really matter to the user all that much. So I said, OK, well, what are the 7 most important from the point of view of the user, right? So it kind of like cut off all those other ones which are kind of like implementation related. It gave me 7, and I thought that's a little bit too much. So lensing is when you start saying, okay, I'm asked for 7. Let me go and ask for 4, for instance. And what it does is it kind of like works from that basis. And it's not like it's going to drop 1 or 2 or more of those 7. It's going to go and reevaluate, and it's going to go and say, okay, if I have to constrain the number of responsibilities I'm finding to a particular number, it's going to attempt to go and do that fitting for you. And it might find something that's kind of useful for you. Even if you don't choose to act upon these things, like to go and extract a class from this class or something like that, it's yet another way of going and looking at what's going on in the system. And that's very powerful, you know? How many times have you tried to explain to somebody what a responsibility is in code, right? And it's kind of like, it's tough. It's kind of a nebulous thing. But this is an area where LLMs can kind of go and give you a bit of weight and power, okay? So, you know, carrying this a little bit further, it mentioned a bunch here, like 1 through 4, and I said, okay, call number 1 the scheduling responsibility and extract it to another class. And so it goes and does that work of extracting to another class, shows you what this looks like. Now, I can take that code and just drop it into my IDE and sort of run with it, right? Put in production immediately, yay, right? No. Here's the thing, with this kind of stuff, you may have tools that are tuned towards going and producing much better code, right? But some of these general purpose tools can at least give you an idea of where to go in what direction. So I often have this distinction between tools I'm using to go and work with production stuff and ones that are more general that I can basically use for ideation. And that's what this kind of stands into. I'm not going to drop this code into anything else. I'm going to basically use it as a reference. That gets us to the notion of generalization and specialization and tooling. Okay? Gwern, if anybody knows who Gwern is, but he writes all these really insightful essays and has for decades. But he came up with an essay years ago called the scaling hypothesis. This was back in the early days of LLMs, and he was basically pointing out that it seems that they become way more capable the more data they've been trained upon, right? And there was like this thing of going and looking at that curve and saying, where will we be in 10 years? So we get all this data, right? But the capability tends to increase with that. We've encountered limitations since then. It seems that we're in this position now where we may not be able to get enough data to train further, so we're generating synthetic data and stuff along those lines. But the thing I bring this up for is because we're in this interesting race right now. And the race is between specialized tools that, say, are focused on coding, for instance, and then the general capability increase that happens with the general purpose tools, like the ones produced by Meta and OpenAI and stuff like this. So you can have a specialized tool, and it's good, but it is also going to be so specialized quite often that it won't go and give you the general knowledge capabilities that you need from another tool. So I like to use both of them, right? If you're using a tool that's focused and embedded in an IDE to do coding tasks, great. But for the ideation stuff, I like to use the general purpose tools because they tend to be a little bit more advanced in approaching problems from a wider perspective. So keep them both and basically use them as you see fit. Here's another technique. I call it using side-by-sides. It's kind of like a cluster of techniques more than anything else. So the thing is, which is common across all these things is you basically have what's generated by the tool and what you're generating, and you're basically going and contrasting them in various different ways for different levels of insight. So the first side-by-side is offer, then ask. So you create something, then you throw it at the AI, and you say, OK, it's like, give me an alternative or a critique for this sort of thing. And there's so many different ways of doing this, right? It'll give you something. It'll give you some nice knowledge about these things that you can see. Often things like checking for standards, for instance, just checking for security, all these other things. And this is a very common way of going and approaching the use of LLMs. It's like, let me go and use it to check the stuff I've got or present alternatives based upon the stuff that I've got. Another modality is solve and then ask. So here's the thing where you basically have a problem to solve, and you choose to go and solve the problem yourself. And then you ask the tool to solve the same problem, but you don't show it your solution at all, right? And then you sort of, you get an answer, and you're kind of like, damn, I was stupid. It's like, this is terrible, right? Or you go and you say, wow, I was kind of on the right track. Why would you ever do this? This is such a powerful way of learning. It really is. It's kind of like, I remember when I was taking mathematics in school, the professor said, oh, I'm going to tell you the secret to getting an A in this course. What is it? What is it? Do the homework. Do the homework, right? You have to basically test your mettle against the problem, right? And the thing is that I find over and over again, if I basically try to solve a problem, and I try really hard, and then I see another solution, that's going to stick. I have done the work, invested the time and energy into something, and then seeing the alternative goes and sort of like, makes something a little bit more, remnant for me. Okay? So useful thing to do. This is the one that everybody wants to do. You ask for something, then you just go ahead and use it, right? And it's got its upsides and its downsides. But the key thing here is to recognize that if we use things directly, we have to basically confront the quality issue right away. We have to figure out how do we actually know whether this thing is suitable for use, that kind of thing. But we're making strides on that. We'll talk more about that later. This is the one that I really think is preferable in many cases. Generate something and then use it as a model for your own solution, right? So ask for 3 different alternatives for something, look at them, see if it sparks other insights. Do that stuff in a work over here, and in your IDE, basically go and do the work to go and sort of do the stuff with tests that you need to do to go and carry things forward. It's like I'll generate small pieces of code as long as I understand them and I can write tests for them. I'll basically use those particular things, but it doesn't take too long to go and move beyond your own personal context window and get to the point where basically you don't understand what's produced and you're tempted to just accept it. And then you know that's wrong, right? You have to understand what it is you're producing, what you're doing, right? Okay, here's another technique. And maybe I should find a better term for this because I don't know. How many people know what a Pidgin language is? Some people, okay, right. So if you have people from 2 different countries, 2 different language communities, and they need to communicate with each other, quite often is they sort of like find some subset and alteration of each individual language in order to go and actually communicate. So like Creoles, for instance, are like this, right? So it seemed like the closest word to what it is that I was kind of like discovering with this. We have some code here, okay? And this is like a part of a class in a system, and I wanted to write some tests for it, and I want to go and generate some tests for it. So I can type in, for this class, please write me a test for the grip method and produce it in JUnit, right? I could do that, right? Or I can do what I did, just trying this out and seeing whether it worked or not. I just typed this. Did that work or not? It worked, okay? This is kind of like this. There's no particular programming language here. This is just kind of like an abstract syntax to actually do the thing I want. And you only kind of like find these things through experimentation, right? You try something out, maybe it doesn't work. In fact, in this example, originally I did this without using the word test. And it worked one day, and then the next day it didn't, right? So I decided to go and put the word test there to go and kind of like nudge it in a particular area. And the reason all this stuff kind of works is that basically all the training that happens with LLMs, they have vast corpuses of data they've kind of like used for training, and also instruction tuning, basically telling systems how to go and actually answer questions and basically be very amenable to questions. You can get this kind of thing, and it works out pretty well. Here's the test. It's a very simple, stupid test, but that was produced, and using Mockito and everything like that. It's even simpler than that. If I want to ask a question about some concept, I hardly ever use a question mark anymore. I just type the noun and see what happens. And quite often, it'll just give you information, because they are eager to please, these tools that we're using quite often right now. Here's another one, making waywords. And I think this is really kind of like a transplant from how we behave as programmers and using some of that to leverage the tools that we have here. So I was working on something a while back. I wanted to go and see what the refactoring capability was for some of the LLMs I was using. And I had this interesting thing I wanted to do. I had this method, and it was basically going and using the date class in a language. I wanted to convert it to date time. It was a relatively straightforward translation. But I wanted to do that only within the method while keeping the public interface of the method the same. So I tried to write out what it is I needed to have here. I said, OK, convert all uses of date to date time in this method, but maintain the public interface. Requires converting all the date parameters to date time after they've been passed to the other method, converting date to, and all these little caveats around this sort of thing. And it seemed to work out OK, right? And so I'm like, OK, well, I've done this. What can I do next? I can say, OK, do this to the other method also, right? I'm going to keep on doing that to a bunch of different methods. At a certain point, you're kind of like, well, I don't want to keep saying do this, right? So you say, OK, I want to basically say something like this. I want to basically make up a word, intralate, type X, type Y within a method. So call the operation I just performed intralate. I want to be able to say intralate type X, type Y in a method M. And that seemed to work a bit. The thing I wasn't really, didn't really discover at that time is like you can explain abstractly what you want, but quite often giving a bunch of examples is the best thing you can use to kind of settle on these things. And so this is nice. I have this intralate refactoring. Big question is, how do I actually transfer that from one session to another? Don't know, right? And it's funny now because a lot of vendors are actually going and sort of persisting knowledge across sessions for you, and that's good, but you don't have a lot of control over what knowledge that is yet, as far as I'm aware of. But the word intralate, where does that come from? I made it up. I tried to find the best word I could for this kind of thing without going and using like a big phrase. Another example of this. well, just to elaborate on this particular thing. I wanted to go and generalize interrelate further. It's kind of like if you're going and taking a method and saying convert all uses of one class to another inside that method, that's fine. But what if you want to do that to an entire class? The notion of a public interface is different. And so you run into all these things almost immediately. It's kind of like, what is the inside and the outside of the method? We don't use the same terminology for inside and outside for methods as we do for classes, as we do for services, for instance. So it's kind of hard to approach this with existing words that exist in our language right now. So examples are really the key for this kind of thing. I found this other thing I was kind of working on. It's like I want to go and sort of like move code in Ruby to a particular style, where I just have like these method chains, chainify things as much as possible. And before I thought of the word chainify, I just said, OK, just call this Floya, because Floya is a made-up word. And it's like, OK, I understand that you want to go and do this. And I'll basically go and use the word Floya to go and describe this. Whenever you say you want to Floya a method, it's going to go and do this work of chainifying things. And later I thought, OK, chainify is a better term, so I'll just go and call it that. This is what a wayword is. It's basically a word that you use to act as like a variable or like a method name for things within a session. That's a very powerful thing. You can actually, like, if you've generated 15 examples in a session, name one of them, and then basically use that short-term name to go and describe things that you're working on. And a funny thing about this, too, that this kind of points to, is that I think about this an awful lot. It's like, how many things are there in the world that we don't have words for? And it's kind of funny with LLMs because we can kind of approach a bit of an answer to those questions. I think they were saying for GPT-4 that they basically have representations of 16 million. There's 16 million often interpreted patterns within an LLM. So when you actually go and ask it a question, for instance, or prompt it somehow, there's patterns of activation within the networks that are inside the LLM that they're able to go and actually sort of identify. And what they've been able to do is kind of like look at these things and say, OK, you can look these up. And you find that there are certain things that kind of are, they all have this thing, and it's a concept that doesn't really have a word for it, right? So here, phrases relating to things, especially humans being flawed. And these are all the places. It gives you a bunch of examples of where this particular activation is occurring. And that's the common thing among those things. So I think it's kind of powerful to recognize that there are things that we haven't really we don't really have words for yet. And it's nice to go and actually think about the fact that not everything is directly approachable by language. And if we have that mental frame, we can often go ahead and sort of like find ways of going and describing things that we're working on and think out of the box a bit. You ever heard of this book, Thinking Fast and Slow by Daniel Kahneman? Okay. He talks about system 1 and system 2 in human cognition. Okay. And basically system 1 is basically like pattern matching and sort of doing that kind of stuff. System 2 is about going and producing orderly steps of operations to do things. And when you look at it from a cognitive point of view, these really are two different parts of the brain. That's just the way things work. So the thing is, LLMs are very good at system 1, all the pattern matching. And there's this interesting thing that goes and points out what the difference is with this kind of stuff. It's called the Sussman anomaly problem. You have all these blocks, and you label them, and then you list out all the operations that you can do to go and sort of like change one pattern of blocks into another pattern of blocks. And then here is a list of all the rules. Okay? And so essentially, you have those rules, and you can ask a planning software to go and do this for you. And that's great. But they tried out something different. They said, OK, let's go and take, in this description of the problem, let's go ahead and change all the nouns and verbs to something different as long as there's a one-to-one mapping between them. So this becomes attack object, feast object from another object, so come object over come object. And it's kind of like, it just goes, it's like a one-to-one mapping. We just have a mapping to just arbitrary words when we do this. And when we do this, it's kind of like, it's interesting to go and notice. The original problem, they called it blocks world. And this thing where you have the translation, they call it mystery blocks world. And if you look here, you'll see that the performance is ridiculously low for mystery blocks world. It's kind of high for blocks world, right? And the thing that's kind of interesting about this is essentially it points out that when we are training in a transformer system, essentially it is basically merging structure and semantics at a very deep level, right? When you change the wording, it's kind of like you don't have the structure left behind all that easy. So it's funny to go and know where this is actually going to go as things progress. Maybe a lot of LLMs will start to introduce planning software that uses it internally. I don't know. We're going to have to see what happens with that. So that's what happens in base LLMs, and it might be that we get better planning capability by them using adjacent tools. There's also this thing that people are discovering with LLMs. It seems that solutions that involve recursion, just seem to be kind of outside their grasp right now. Anyway, I've described a bunch of different techniques, and I have a bit more to go and talk about. Just go and mention, though, there are a bunch of other techniques you can use when you're working with LLMs to go and do a lot of this work. One of the things I love doing is going and saying, OK, you've asked for a solution to a problem, or you've asked for a piece of information. There's so much lost opportunity to just going and taking that solution at once, right? Ask again and see what happens. Chances are it will be different, OK? And it's kind of like, if you're just accepting the first answer, you may not have explored much of the space. Another thing which is great is just asking for n solutions to a problem. Ask for 3, right? Then you can compare and contrast those, right? When you ask for 2, it's a special case. It's kind of like when you ask for 2, your mind is going to focus on the differences between those 2 things. So I often ask for 2 in cases where I need to go and actually sort of like see differences. Another thing which is important to recognize is that when you're asking for coding solutions to problems, pay a lot of attention to the names that it produces and uses. Because quite often those are things that are like in your domain that you might not have thought of, right? Or in an adjacent domain. They might lead you to better naming decisions in the context of what you're working on. Okay? Understand the generated, just pointing out that when you are generating things, take the time to go and understand it as much as you can, because that's how you learn, right? We can train these systems, but we learn through understanding deeply the things that we've generated. Yeah, we'll talk about a bunch of those in a little while. Let's talk about cost and risk for using LLMs for development coding. Okay? I kind of look at cost and risk as being roughly the same thing in a way. It's kind of like if you have a very expansive notion of what cost is, anything that's risky is going to have some kind of cost, either financially or in terms of human life, human quality of life, the ecosystem, all these other things. So to me, it seems like it's kind of like one concept in a sense. And quite often when we're developing, we're in this space of thinking like everything must be correct or else, right? But the thing to recognize is that we work in all these different domains within our industry, right? And even in a project, we have different kinds of code that we have, right? So in terms of like low risk things, if you're generating scaffolding for something, like CI/CD pipeline and stuff like that, you'll find out very quickly whether it isn't working. Generate some of that, look at it, review it a bit, Support code for things that you're working on, internal tooling, if you're experimenting with things. Disposable tests, you're going in and doing automated testing, but you want to go and do it to go and check on something, and you may not care to persist those tests. You can easily generate tests in many cases for these things. The things which are kind of much more risky and costly are things that are consequential for the user, right? Things that are going to go and basically put their life or money at risk. Key customer value features, you're in a market and you have all these customers, and if you mess with one of the features they depend upon, you can really be in trouble. And the other thing is when you're doing things like embedding LLMs inside of your software, dynamic policy choices. It's like if you get something which is hallucinated and wrong, and it costs you lots of money because of that, because that's directly in the pipeline of your system, rough, okay? So talking about the actual domains for a lot of these things, in terms of cost, risk, gaming is a great fertile area for this stuff. It's like if you are making games, quite often you can do things that aren't critical in a sense that they will actually cause people to switch to something else sometimes, right? Tools for creators, quite often they are much more tolerant of problems with their tools as long as they get to create what they want to create. Entertainment, startups, very mature markets where they can actually have a little bit of leeway with things in terms of what their customers expect. On the high end, we have regulated industries. If you're making medical device software, you don't want to incur a lot of risk, life, fortune. The other area, too, is like low switching cost. It's kind of like if you have basically, well, it should be high switching costs. It's like if the switching costs are very high for your customers, they might tolerate a little bit more from you in terms of like things that you might produce that might be a little bit off. Medical law, naturally. It's like in those areas, it's very risky and you want to be very careful about those things. So we have a vast panoply of different places where we can try out AI to different degrees, okay? Here's the big thing that I think we're all kind of like approaching now. Review fatigue, right? In fairness, a lot of these tools that generate code are not new for us. We've had code completion in IDEs for decades, right? But the thing is, there's always this thing that happens when something generates something for you. You're looking and you're kind of like, here's another thing to understand. And you either decide to go down the rabbit hole or you don't, right? And if this is happening constantly when you're working with a tool, you're really in a rough situation. So you have to be able to manage your energy when you're working on things and understand how much you can review consistently in order to go and actually just sort of do the things you need to do. We can call this attention debt. I don't know whether that's the right term or not, but since we use the word debt for a lot of things, maybe. So review is harder than the incremental learning that happens during development, right? When we are working on something, we are developing context in ourselves, and we basically add onto that context in a work session, and that's great. But the thing is, it's kind of like if you're asking something to generate something for you that's a bit different than what you had before, you have to build up that new context, and that's another piece of things that you have to do. It can be very rough at times, so you have to basically manage that. And you know, at the end of the day, it's kind of like AI has to pay for itself, right, with regard to frustration and fatigue. One thing about developers is that we have very low tolerance for things that are going to get in our way, right? It's so true, right? So I think there are a lot of developers who have been really burned by the use of AI tooling up to this point. They're kind of like, oh, no. You know, it's kind of like, I can't handle the fact this is going to be wrong sometimes, right? And that's fair, but I think that the way things are working in the industry right now, there is such an incentive to try to get this stuff right. You know, that I think, you know, if you basically sort of just flip the bozo bit in the very beginning, it's like you're going to be losing things as things go along, right? So we have to go and sort of like be, you know, aware of that and, you know, dip our feet in the water periodically. Okay, how many times have you ever heard that this is a good idea? Work in small chunks, right? Doubly so with AI, right? If you're going to generate something small. If you're going to use something that you generate, generate something small, right? You can generate something big, but understand you may not understand it fully. Risky. Don't do very much with that. So we get to adjust our scope with these things. And they're really good at adjusting scope for, you know, with us. So we can do that kind of thing. So yeah, it makes a big difference. And here's another thing which I think is very powerful too, is essentially, it's kind of like you have to get used to discarding things that don't work. If you can, right now we're at a point where brainstorming is essentially free. But you have to go and sort of like say, okay, this isn't the thing. I close that session. Here's the other thing, right? Keep some active sessions available, but the ones that are experiments that are not working, get rid of them. And this is very much the same as tab management in a browser, right? I mean, how many people have 10,000 tabs, right? There you go. Aren't there 3 or 4 that you use, right? More than often than others? It's the same problem. And you find that basically the more that you're able to go and sort of like dispose of the sessions that aren't working out for you early, then you're better off. Hey, so automated testing, let's talk about that, right? So for people who don't know, I'm the legacy code guy, right? And I basically try to go and help people get tests in place for things. And I was so thrown by this, the fact that people are going and using AI to generate tests. And I thought, the last time people did this, it really was a travesty. And the reason why was because they could never get the names right. You know, it's kind of like they'd have things that would work structurally in analysis. And then the name of the test would be just ridiculous and it wouldn't quite work. Things are much better now. And I really had a bit of an epiphany about this. And I think that the key thing to recognize is that we can basically generate tests now relatively easily, but there's nothing that says that we have to go and keep them, right? And this is a funny thing to think about, right? When we have a code system, we have the code, and that has like all of the behavior associated with the code that's produced by the code. And we have the tests, and that tests describe that behavior. These are 2 repositories of behavioral description, okay? And when we have this, it's kind of interesting to notice that we could do things like, hey, let's delete all the code, and just basically use the tests as a description of the system and rewrite the code to satisfy the tests. So have you ever tried that at all? It doesn't really work, I mean, but it's kind of close in a way. It's a fun exercise with a tool. Essentially, when you do this, try this out. Take some project, go to the folder that has all of the code and basically delete it, and then have the AI work on the test and produce code that satisfies the test. And you start to learn very quickly what the capabilities happen to be, where they stand right now. But the powerful thing with this to recognize is that essentially, this is a nice thing about this, is that essentially, if the tests are gone, the code is the repository of the behavior. It is not the behavior you intended necessarily, it is the behavior that is real and exists and is in production. So what we can do is we can say, write tests that basically test this code, and if the tests pass, they are valid descriptions of the behavior, okay? This is great, this is powerful. This is characterization testing, as I talked about in the legacy code book. But here's the thing, those aren't records of intention. You may not want to keep those tests around. We're in control. As long as the behavior in the code is constant, we can go ahead and generate all these tests. We can keep them or not, but the thing is, it's kind of like they will be valid as long as they actually pass against the existing code. It's an important thing to recognize. So Rigor, I'm going to talk about this. It's a very funny thing with this, because I had this thought a while ago. So as soon as people made this leap into transformer architecture and large language models, the first thing is like everybody who's been into science fiction leapt up and said, yay, generic intelligence, artificial intelligence is going to be the next stop. We'll be able to go and do that very quickly. And that's cool, but then the thing is all the engineers said, okay, well look, let's go and use it for design and writing code and testing and all these other things. A lot of what we do as engineers is rigorous, right, in the sense that it has to be right. And it's funny because the way an LLM works, it's kind of like this stack of probabilities. and actually getting something that's going to be deterministic in what it generates is rough. They were not built for determinism, in a sense. So that's why I like them for ideation a lot. I think that we're going to, over time, make them more and more rigorous. But that's almost like tangential to what they really are. They're really more like people in a sense. You know, and it's kind of like we make mistakes, they're going to make mistakes also. And it's kind of like that's the place where the creativity kind of lies. If you've been reading around a lot or watching videos, you'll see people are saying, hey, hard to get rid of hallucinations because that's really what creativity is in a sense. So I like to do this thing with technology of going and saying, what's it really good for, right? There's what we want it to do, but what's it really good for? This reminds me of a bit of a story. There's a band I listened to a long time ago, and they basically used one of the very first guitar synthesizers by Roland guitar in Japan, right? And so they went on tour, and the guy from the band is going and saying, he got to meet some of the engineers. He said, when I do this, I don't get quite what I want from this. You know what the engineer said? You're not supposed to use it that way, okay? But he did to great effect. It was really a powerful bit of music that the guy had created. And this is the funny thing, is that essentially it's like we have our preconceptions about what we want to do as engineers. But it pays to look at what are the characteristics of the thing that we have and see them independently of that. And then basically see what they're capable of doing for us. And this is an important thing to go and recognize, okay? It turns out that we're going to get better and better at the rigorous thing right now with AI. But the thing is, it's really, for me, it's just like the ultimate brainstorming tool. And that's a powerful thing to go and recognize as well. And that's what the technology can do for us without any alteration. We don't have to beat our heads against the wall. We can, and we're going to get payoffs for this, right? With code in particular, it's like, the thing that's kind of nice is that we can try to generate code, and then the compiler will tell us whether it at least compiles, right? And the tests that we produce are going to help us understand what it really is in the right area of behavior. So we have to do that diligence of going and testing it against a standard, and test can be a good standard for that. And a lot of the tools that you're seeing now, they're doing like automated refactoring and stuff like this, using AI and stuff like that. They do have another layer where what they are doing is actually going and comparing it against some kind of checks internally to make sure that what they give you has a higher standard of acceptability than you might get from a general LLM. That's kind of cool. So anyway, that's kind of where I wanted to go and kind of take this. I guess we're all we're much less concerned than we were before about losing our jobs and due to AI that it's going to replace us. We've been around enough now to see that's not going to happen right away or anything like that, right? But I think that even beyond that thing of like just what our recent experiences, there's this thing which is very typical, and I call it like the tech want staircase. It's kind of like whenever we develop new technology, it satisfies needs or wants that people didn't have before. And then it goes and leads to new wants and needs. Because human desire is always going to be far more in excess of what we're able to do as humans, right? So the rough part for us is that people are going to go and ask for far more powerful and extensive software systems than they do today because we are capable of doing that. And this is very much like the thing that we had, like the transition from assembly language to structured programming languages, right? We were able to do so much more. Did that stop people asking for features and stuff like that? No, we asked for much more than we did before. So this is just what's going to happen with these things, right? So I encourage you to go and basically dig into these things, look into what the technology does for you. I think it's kind of important to keep up with it, even if you're not using it directly. And it depends on where you are. Some places just say, can't use this stuff at all, right? But as developers, you can always take some time off to the side to go and explore these things and see what they do, right? So a friend of mine basically said, it's kind of, this is the worst it's ever going to be, just like the, so it's like it's going to get better. Yeah, so our trajectory, we learn to ask better questions. I think that's a key thing with AI, is that the more we use it, the more we start to see different perspectives that we can use to inform our work. And here's the sad part, is the interaction is only as good as we are. We have to be able to ask good questions. But the best thing about this is that the tools make us better. They encourage us to ask better questions too. So you can look at this as like the ultimate training aid for yourself, right? Want to learn about anything? Dig into it. The answers are there. And by the way, I'm working on a book about this. I'm calling it AI-assisted programming. It's probably not the name it's going to have eventually because somebody else has a book with the same name, so I get differentiated a little bit. But really, it's about a third of the way done right now, and it has a lot of these techniques plus a bunch of other ones. And it may seem like a very foolish thing to do this when the technology is in such flux and things keep changing. But I'm having fun, and it's hopefully that fun will help people, kind of like try some different things and get some value. So thanks very much.